Hi, today I want to talk about light and specifically the reflection of light. So you all know what reflection is. If you look in the mirror, you see your reflection. When we talk about light, the reflection of light basically means that when it hits a boundary of some sort, it reflects or bounces off that boundary. So imagine you had air and a beam of light, and this is what we would call a ray diagram. Ray diagrams show like the direction of a beam of light, for example, and that beam of light is coming in and hitting the surface here. Well, some of that light is going to bounce off the surface and come back that way. Now, maybe all of that light will. It really depends on the boundary and some other specific conditions. But, can you... say it's a mirror, for example. If air hits the mirror, it's going to all bounce off. If it's water, for example, you're going to have some of the light that passes into the water. That would be called refraction. But even if you do get refraction, you always get reflection. And reflection happens in the same way, more or less, regardless of whether it's air to water or air to a mirror. So either way works. Let's just keep it a mirror, though. And reflection, in principle, is really simple. We can just say the angle of incidence, which is theta with a little I to it, equals the angle of reflection, which is theta with a little r. And we measure these angles from the normal. Now, the normal is different than what we've been doing for a lot of measurement thus far this year. The normal is this imaginary line that is perpendicular to the surface. So imagine, let's get a different... Here. Imagine I create this imaginary line here, and this is what I'm going to call my normal. And the normal makes a 90-degree angle with this surface, the mirror. And if we want to measure from this, we tend to measure theta I and theta r. So the angle of incidence would be this angle between the normal and the incoming ray, and the angle of reflection is the angle between the outgoing ray and the normal. And we just have to know, if we see this ray diagram, we can draw the normal straight up from it. And you can use a protractor to actually measure these angles pretty easily. Just keep in mind that you want to hold the protractor in the correct direction. A good way to do this, for example, is to say, hey, I want to know how big that angle is, so I'm going to actually point 0 up there and measure this way, and I see that according to this, it's at about 25 degrees. If I want to measure theta r, I'm just flipping it over, and I'm going to say, hey, look at this, it's at about 25 degrees, 10, 20, 25. So that is how we measure our angles, theta I and theta r. Now, sometimes you can actually see ray diagrams coming through like this, and you might have, boom, there, there, and it's not a particularly good drawing. And so your normal line would actually be, again, it's normal to the surface, so if that's your mirror, normal means 90 degrees to your surface and makes a right angle, so theta I would be there, theta r would be there. So you might have to measure them in a slightly different way, but regardless, they're always measured as compared to the normal of your surface. And they should always be the same. It's really straightforward. The hardest part of this is just measurements, making sure that you measure it correctly. We do have two types of reflection that I want to mention. The first one is called specular reflection. And that's like in a mirror where you get a clear image. And it would be like imagining you have light rays coming down like this, boom, 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 and they all hit a surface here. They're all going to bounce off like that. So for all these, the angle of incidence equals the angle of reflection. You could draw a separate normal line for each of those, and the normal lines would be like And for all of them, the incidence is going to equal the reflection. And that's called specular reflection. And that's going to get you a nice clear image like you're seeing in a mirror. The other kind of reflection you will see sometimes is called diffuse reflection. So I'm going to erase this and show you what diffuse reflection looks like. And in diffuse reflection, there's no clear image. So if you shine light on a table, for example, you might see a bright spot of light bouncing up towards you. Like light on a table. But that light is not going to show a clear reflection. And what you get with this is, what you find is that the light still will have an angle of incidence that's equal to the angle of reflection. That's always going to be the case. But because the light's hitting a bumpier surface, basically, what you get for those angles is going to be somewhat different. So your normals are not always going to be perpendicular to the greater surface, but they're going to be perpendicular to the jags in the surface. So you can see something like this might have different normal lines. So even if your angle of incidence is equal to your angle of reflection, you're not going to get an image where the light that bounces off the surface is all going in the same direction and can easily focus when it gets to something like your eye. That does it for this topic. I want to thank you very much for watching.